All right, so figured out finally that how to display the screen. Excellent. So what we're going to do today is we are going to go to Module 6, and we're going to do another in-class exercise today that I guide you through. This one's actually particularly fun. Oh, did I accidentally wipe it out today? Interesting. Okay, let's see. Is there view page history? Yeah, I accidentally wiped it today. So let's go ahead and restore this revision. Great. Except that what we're going to do is we're going to take this, we're going to copy this. This happened basically an hour and a half ago. Don't you like how things like this work out? Okay. Whoops. Yeah, even I make mistakes like this. It's perfect. So don't beat yourself up if you make mistakes. A lot of these mistakes these days are super recoverable from. Where you accidentally delete a page or something. Okay. There we go. So I've pasted in the correct exercise. Today we're going to learn how leap years work. So, all right. Now this assignment is called Blame Pope or Blame Pope Gregory the 13th, mainly because it's leap years. The way we do leap years these days are, I guess, his fault, and we'll see why. So first, let's go over to Wikipedia for a second. I promise this makes sense. We're going to actually look at George Washington's page. Okay? We're going to look at George Washington on Wikipedia. Why? What does this have to do with leap years? Okay? Oh, did they get rid of the dating. Interesting. So Wikipedia used to have a note right over here about his birthday. Okay? Which is 1738 through 1799, which is a shame that they got rid of it because it was such a good example for this. It's still down here? Ah, yes, it is. Where is it? Okay. Early life, A. George Washington was born February 22nd, 1732A. Okay, so they just moved it. February 22nd. But if we click on A, it will say contemporaneous records use the old-style Julian calendar and the Annunciation style of enumerating year, recording his day of birth as February 11th, 1731. So, during George Washington's life, there was actually a calendar change. The British calendar, New Style Act of 1750, implemented and altered the Gregorian calendar with the start day of January 1st. The changes resulted in the dates being moved forward 11 days and in advance of 1 year before those between January 1st and March 25th. So, does this mean? Well, the Julian calendar works on the rule that you think leap years work on, which is very simple. A year is a leap year if you divide by 4, right? If the year is divisible by 4, it's a leap year. And that works like most of the time. Most of the time. For doing it with the Gregorian calendar, which is the current calendar we use. Now, I guess I should ask, does anybody know why we have a leap year in the first place? Why do we put in this extra day every so often for the leap year? Anyone? Yes. I mean, yes, but why do we add that extra day to February? Or any day, or anywhere. It doesn't matter where we add the extra day. Why do we add an extra day to the leap year? So because there's how much? There's about 365 and a quarter days in a year. In an astronomical year. The amount of time it takes the amount of time it takes the sun to rotate sorry, not the sun, the Earth to rotate around the sun. Okay? And of course it makes sense. Why would, it would be a very strange coincidence if, the rotation of Earth's rotation, Earth's revolutions, matched up perfectly with it going around the sun. Sorry, its rotations in place line up directly with the revolution around the sun. It would be a weird coincidence if that was the case, right? But it doesn't. So if we look at a leap year, okay? If we look at leap year, okay, it's where we add that 366th day into that. An astronomical year lasts slightly less than 365 and a quarter days. If we look over here, astronomical year, where is that? Oh, you've come on. Wikipedia, they change things every so often so that they can, and that messes my facts up sometimes, where it just doesn't say, oh, this is how much time it takes for it to do. So anyway, oh, there it is. For the average is, that's for the Gregorian calendar. It's approximation, but you don't have, but it no longer has the actual amount of time. Come on. Sorry. Normally I can just click on it and it says it. So 300 and that's bum. So let's see. So animal, sidereal, tropical summary. So on average, they say on average a Gregorian year can be 365.2425 days. Okay, which is not quite 365.25, which is the amount that you would use with the with the Julian calendar. If you every 4 years of leap year, that makes basically every year on average 365 days long. However, what happens over time is that the days and the seasons kind of started shifting because the calendar was out of whack with where the sun actually, where the Earth was actually in position with the sun. So there was this drift that had gone on, and it had been going on for a while. Basically 11 days worth of drift, which is why the calendar was shifted 11 days. So what happened is that Pope Gregory, in the 1500s, he commissioned a new calendar. Now it took a while for everybody to adopt it. Some countries did not like adopting it. It took until the late 1900s for everybody to adopt it, but it is now the overall civil calendar that is used these days. So the reason I call this exercise Blame Pope Gregory the 13th is because it's his fault you've got to do this now. But he's a big man. I'm sure he could take it. So what does that mean? The rules for a Gregorian calendar are actually a bit more detailed, which is as straightforward. But I'll try to be as straightforward as possible. A year is, if it's not divisible by 4, there's no way, shape, and form it can be a leap year. Okay, right? This year, 2024 is a leap year, but 2023 definitely was not. 2022 was not. 2021 not. Right? A year that is divisible by 4 is a leap year, except if that year is divisible by 100, unless that year is divisible by 400, in which case it is actually a leap year. There's the rules. Okay, so what do I mean by that? I have some examples here. 1644 is a leap year because it's divisible by 4. This year is a leap year. It's divisible by 4. Right? We're still in 2024, right? I'm sorry, ever since the pandemic, everything kind of just became one long blur. It's kind of been a bit difficult to keep track of the years. And let's see, 1645, it's an odd number, no way it can be divisible by 4. The year 1600 is a leap year. It's divisible by 400. It's a leap year. 1700, sorry, the year 1700 is not a leap year, okay? Because it's divisible by 4, but it's also divisible by 100. So if it's divisible by 100, so leap year is not a leap year if it's divisible by 100, unless it's divisible by 400. Okay? Now, it's a bit weird to think of that. The reason you aren't taught this in school is because you don't need to be taught it, right? The rule, oh, it's a leap year if it's divisible by 4, is because it works. It's worked from basically 1904, and it's going to continue working until the year 2100. Okay? And then then the kids in 2100, they have to worry about that problem. Okay? But we don't, unless you live that long, which I hope we all do. In which case you can actually confidently correct everybody. So, anyway, the leap year thing. So what happens on a leap year in our calendar is that we add one extra day to February. It goes from February 28th to being February to having 29 days. That's it. Okay, that's what happens in a leap year. Now some calendars do weird things, like some other because the Gregorian calendar isn't the only way that things have been charted. Lots of various religions have different ways of charting calendars. For instance, there are a bunch of religions that say a leap day is really silly to add in a leap year. Instead, we do a whole leap month every so often. That's how it works. So, So time is actually kind of difficult. It's actually really interesting to try to track. And there's I've linked in the footnotes of this PDF a very good very good YouTube video on the difficulty of trying to validate time and time zones and what kind of mess that is. Because some countries use them and then some countries don't, and then some countries use them in a way that doesn't make sense, and then some countries have the entire country being in the same time zone. And then what the heck do you do for those poor researchers who are getting close to the middle of Antarctica, So where all those time zones converge? Are they just lost forever? So anyway, what are we going to do? So what is today's objective? Today's objective is to make a date validator. What we're going to do is that we're going to ask the user to enter a date in the American format, which is really, it's month, day, year, which always weirds me out because it's not in, it's not in what seems like smallest to biggest order, right? You'd think the days would be first or last, not in the middle. But it's going to be this format: number / number / 4 more numbers. Okay, valid months are 1 through 12, right? Because January is 1, December is 12, everything else is in the middle. Okay. September, April, June, and November, if you remember the rhyme, all have 30 days. All the rest have 31 except for February. Okay, so that's how we know. Okay, and February will have 28 days unless it's a leap year, in which case it has 29. So the reason I like this assignment is that it doesn't matter if you've been programming for 5 weeks or 5 years. This program is just as difficult no matter what because of the logic involved. It's kind of annoying logic that you have to detangle. Unless you've got this kind of detangled logic, it's a pain. So where should we start? The answer is, well, since leap years are the exception, we can basically focus on everything but the leap year until the very end. So what we're going to do is we're going to build our Python program. So idle. We'll boot up idle. And we'll start this. And again, what you're going to want to do after this is there's a Dropbox linked, okay, for this, okay? So this is something you do turn in, but again, it's one of those in-class exercises, okay? Which means I'm going to be checking it for, did you vaguely attempt to follow along, kind of thing, as opposed, and of course you can always come back to this video, so as long as you drop it into this Dropbox Dropbox, you will get credit for it. Okay? So, let's see. And then what I like to do is to split up the windows in half like this. And then I'll save this to be desktop. Leap. And I'll just call this Leap because why not? I've sometimes called this Blame, but whatever. Okay, so the first thing we want to do is we want to ask the user for this, for their input, okay? Months, days, and years. And then we're going to completely ignore that. We're going to comment it out until it's done. You either want to be asking for input to be the very first thing you write and then ignore it because as we'll see in a minute, or you make it the very last thing you write. The reason for this is because asking the user to input something every single time until you're ready for it, to constantly ask, it kind of slows the testing down. So it's much easier to just kind of temporarily hard code something in. All right. So what we're going to do is we're going to say date is equal to input. Please enter date in month/day/year format. There we go. And then in that case, so here, I'll make this bigger. Please enter date in month/day/day, sorry, 2 days/year format. Okay? And then we get that as a string and put it into here. Now our next step is that we want to basically save those as separate variables. Month is equal to, day is equal to, okay, the questions are for you to complete, and then year is equal to, right? So we're going to get date, and date is going to be some string, right? Date is going to be something that looks like this like a string like this. Let's go with today, actually, 10/01/2024. Okay, so that's going to be that, right? So that's what day would be equal if you put in today's date. Now what we want to do is that we need to extract the individual parts of that. We need to get the month separated out, we need to get the day separated out, and the year separated out. Otherwise, we can't do anything. Now, fun thing I didn't mention at the beginning, although I did write it down on the thing you click on to get here. This exercise requires no loops whatsoever. And it's still a pain. Now, how do we get things out? How do we extract things from this? Well, I actually go into that in the document, in case you need to fall back on this later and review, which is how do you slice a string, right? So we're going to need to slice a string to extract the numbers from it. Now, I'll leave that up on, so that will be your job for a bit. I'm going to leave that up, but before you start slicing, even now, I always find it if I have to slice stuff and I have to pay attention, I always find it useful to do this, where I just kind of put the index number over the string that I'm slicing. Make sense? So I'm like, aha, that gives me an idea of what I'm doing, right? And then that way I can also do this, which is month/day/, and there that will let you kind of work on slicing it. So comments are really useful like that. So here again, in case you need a review on how to slice, here's a bit of slicing. Here's again examples on how to use slicing. So use that to extract the month, the day, and the year. Unpause. All right. So hopefully you made some progress on that. So how do we do that? Well, what we're going to do is, again, we're going to slice these things. We use date as the variable, and slice notation is always going to use a colon. So date And let's go ahead and just line these up. We can line these up. Whoops. Don't need curlies. Let's just go and line these up. You can do that. Okay. So for month, we just need the first 2 bits of this. We don't need, for all these, we don't need the slash. We just need these first 2, right? 0, 1. So this goes up through and includes index 1. But slice notation is always begin to end, and to use some math notation, right? It's always like this. It's always inclusive at the beginning, right? And then exclusive at the end, right? Everybody kind of recognize that from algebra, right? Just another way to kind of present that. So what we want to do is start at 0, go up to, but not include index 2. Now what we're going to do is for the second one is that we just go 3, we go up to, but don't include 5. Now there's 2 ways basically to do this one, right? We start at index 6, and we go up to, but we don't include, well, hold on. I guess I'll put 10 there because, if there was an index 10, I wouldn't like to include it, right? And this, actually, I want to just show you a fun feature of Python that I really love. Month, day, year, right? So I'm going to go ahead and run this. And please enter day and month, year, form. Now you see what I mean by it's going to slow us down. Because I'll have to, put it in every single time. So what I'm going to do instead is I'm going to take this, comment that out, put this in, right? And line these up so that, right? So everybody see now I can test it on the same date every time. And I just need to run it, and now it runs fast. And obviously you'll want to test this a lot. Or test a lot of different variables, but for right now, just for getting things started, this helps a lot. Okay. So the fun thing about this one is that if you want to go, is that slices don't really care about out of bounds, which I found to be fascinating. I think that's good emphasis there, but as you can see, once it hits the end, it just kind of doesn't care. So I love this feature about slicing. You can do whatever you want for that last number, and it's just not going to go out of bounds. If it comes to the end of it, oh well. The other way to do it, of course, which I saw a number of you do, was you just simply say, I'm going to start at index 6 and go up to, I'm going to go up to the end, right? I'm going to go start index 6 and go through it, right? Which also works, right? If you leave the end point blank, it's going to say I'm going to go to the until I hit a stopping point. All right. So now we need to now there's basically 3 things that can be wrong with this if it's to make it an invalid date, right? Now, I'm skipping over something here, but we'll come back to it later. But there's 3 things that we need to do to make that check to make sure it's not invalid date. Right? We've got 3 variables, 3 things to check. The month could be wrong, the day could be wrong, or the year could be wrong. What do I mean by that? Well, the month could be, I could enter something like this. It's maybe it's April, May or something like that, or Jan, February or something like that. Okay? So we only want real months. So we only want it to be in the range of 1 to 12. Okay? Similarly, the day could be out of range. There's no 32nd day in any month. There's no 50th day in any month. So we want to make sure that it's not out of range. Okay? And then the third is that if the leap year's honestly the year's always correct. What we're going to use the year is to see if it's a leap year, right? So So if we think about this logically and kind of just try to constrain a program, we can't check the year because we only care about the year if it's February, and we really haven't figured out if it's February yet. We can't check if the day is right because the number of days in a month depends on how many months, on what month it is, right? So what does that mean? It means we need to check the month first. We need to check the month first to see if it's a valid month, right? So what we're going to do is that we are going to categorize our months, right? Which is just simply put, we're going to simply say, hey, we're going to set it up so that we can check our days. So what we're going to do is we're going to write if statements to categorize these. We're going to have something like this. So obviously we're going to have to put this into real Python. It's a 30-day month else if it is a 31-day month, right? Then we can. So if it's a 30-day month, we can check if the day appropriately, right? If it's a 31-day month, we can check that appropriate. Else, if it is February, and then else bad month, right? So if somebody puts in a month, we'll detect if it's a 30-day month, a 31-day month, February, or if it's not a 30-day month, not a 31-day month, not February, then the only conclusion we can draw is that they messed up, right? They put in something wrong, right? Make sense? So what we'll do is, in which case we can just simply reject it. So what we're going to do is we're going to write something like this. If month, so I'm going to write this. If month, so what's the rhyme again? It's September, April, June, and November, right? So we'll check September first because why not? September. If month is equal to 9, right, if it's September, and I've already messed up. What did I do wrong? Yes?
There was no 0 in front of the 9?
Huh? Integers don't care about that. Except when they do, but that's for a completely different reason. Yes? Yes, it's exactly right. I just tried to compare a string to an integer. Exactly right. So what we'll do is that we're just going to throw int around these to make these a bit easier to work with. Because we're going to need to do some division later on, right? And also it makes it easier to check if things are bigger than another number. So we're just going to do this. It's one of those errors that you'll make a lot, so don't feel bad for missing this. It's that the kind of error that you're going to make a lot and then you're going to pick up on it as soon as the code doesn't run. So nothing to be upset about. So if month is equal to 9, or if it's equal to, right, or month is equal to 4, etc., etc., etc. Okay? So go ahead and try to write these if statements. Let me go ahead and just kind of give you an outline. So what I'm going to do, you're going to have to add the rest of the months there. What I'm doing is I'm putting a word here called pass. You may have seen it in the homework. What does that mean? Well, when the code gets a colon, it expects to see something indented in it, so you can't leave it blank. Pass kind of allows me to leave it blank. Okay? So it allows me to have this code that does nothing. This if statement will do nothing. And then for else if, right, we'd write elif. If elif month is equal to something else, right? And then we'll put a pass down there, right? And the pass should never stay in the code, in the sense that like the pass is always a placeholder. Elif month is equal to 2. Else print invalid month. Not invalid moth, invalid month. There we go. So what you'll want to do is you'll want to add on to these statements, okay? Add on those two statements. Take a few minutes because I want some of you to accidentally make an unintentional error, which will actually not crash the code, which makes it even harder to detect. So don't worry about it. It's a learning experience. Okay. What I don't want, by the way, is 12 different if statements. All the months are on this line. They should be separated by ors. Then the other months are on this line, separated by ors. Okay. So here we're going to be focusing on using the or statement, right? If it's September, or if it's April, or if it's one of the other ones, I will pull up that PDF and put it over here so you can have that. Okay. September, April, June, and November. And I'll pause it now. All right, I want to make sure we have plenty of time for everything else. So what we're going to do now is I'm going to write out what we've got. Now, I went around and I saw a lot of basically at least yes, question? Oh, sorry. The logic that everybody was using was was correct. The month is equal to 9, or month is equal to, what was it, April, or month is equal to June, which is 6, right? Or month is equal to, 11. So those are those 4 months that have 30 days, right? Yeah, those are our 30-day months. So now what I did see, though, from a number of people, which is what I was warning about, and it's one of those things that is annoying for Python because it doesn't warn you about this. This is the only kind of surprising thing about Python, I think, but it makes sense once you know it, is that you write this. And if we were to finish this code, right, so if month is equal to 9 or 4 or 6 or 11, this makes total grammatical sense to a human being, right? This makes a lot of sense. It's easy to read. Oh, if it's any of those numbers, right? But the way you would write that in Python is you would write it instead as if month in 4, 6, 9, or 11, right? That's how you'd write that particular English in Python, right? Is it a member of this list? However, what we wrote here will have a very annoying quality. So I'm just going to go ahead and do this. Print valid 30-day month. Okay, so I'm going to run it, and then I'm going to run it. Okay, so run it. Invalid syntax there, right? I've got to say if month is equal to, let's go with 1 for there. Doesn't matter. So now our date is going to be, let's just turn our date to, again, back to today. If I run it, let's see, block must of elif must end, I forgot to put a pass here, right? That's what it's warning about, right? Well, that's wrong. October is not a, right? We're testing 10/01/2024, okay? And then it's saying it's a valid 30-day month. But if we look at this, none of these numbers are 10, right? October is 10, none of these are 10. So you run it again and again, and you'll get the same results. The key to figuring this out, by the way, is to test something that is something that you wouldn't normally test. A lot of tests, you need to test things you more normally test. It'll say, that's a valid 30-day month. So this statement over here, this month is equal to 9 or 4 or 6 or 11, is giving us true no matter what. Why? Well, the answer is because numbers are truthy, or positive numbers are true, or non-zero values are truthy in Python. What in the world is that? There's this concept kind of so Stephen Colbert, he used to, before he went on The Late Show, he had a show called The Colbert Report, where he basically coined a term called truthiness, which is it's less about actually being true or false than what does it feel true or false, right? It's actually the show was an amazing bit of satire that I particularly enjoyed. And Python has a similar concept with truthy and with values being truthy or falsy. And simply put, values in Python can have a truthiness or a falsiness if they're not part of a comparison. What do I mean by that? Well, we can use the bool to see what kind of Boolean something would evaluate to. So any number, non-zero number, will evaluate to true. But as soon as we try to say, hey, is 0 true or false? False. Anything that's not 0 is true. Okay? And I do mean anything. That's true as well, because it exists. You can think about it as Boolean, as something being truthy or falsy as whether or not it exists. But what's the equivalent 0 value for a string? Empty string. Empty string is false, because it doesn't exist. There's no empty string. What's that mean? It's a 0. That's what it means, right? Makes sense so far? Okay, so what's going on here? Basically, you can read this as if month is equal to 9, or if the number 4 means anything, or if the number 6 means anything, or the number 11 means anything. Well, it does have meaning. It is truthy. So that's why you need to do this repeated check. If month is equal to 11, or month is equal to 6, or this is basically the only time I'll say Python does something unexpected or surprising. Generally, Python's, again, going to do the least surprising thing. Okay? You'll make this mistake a few times, and then you'll lose a couple hours over it, and then you'll never make that mistake again. Yes?
So we can't use the month in the bracket?
Oh, I was going to do that for the else if. You can. There's multiple ways to do something. I was just showing that not the or without doing a comparison, that's going to leave you in trouble. So else if month is equal to month, and we'll do it the other way now, as I mentioned, and we can just make a list. 1, so 2 is already taken. 3, 4 is up above there. 5, 6 is already taken. 7, 8, 9 is already taken. 10, and 12. So that will give us our 30-day months. Okay? And so I'm going to remove these comments, except for that top one, because it's kind of, that's useful there. And now I'm going to copy paste this over the passes so that we can test our code. Valid 31-day month, valid, and I'm just going to call this valid Feb. Okay? So invalid month on 99 now. And now if I test, 01, it's going to tell me that is a 31-day month. And if I test April, it's going to tell me that's a 30-day month. And if I test 02, it's going to say it's a valid February. And if I try negative February, it's going to tell me that negative February doesn't exist. Right? Again, it's very interesting to see what accidental key presses or on purpose key presses a tester will do or a user will do. So there we go. Now, for this one, we can assume, of course, that the human's going to follow directions and enter something in that format, right? Because otherwise the program becomes a lot harder. So we're just assuming that somebody can enter something in that format. They just might be, gibberish numbers. Okay. So now that we know So now that we know this, okay, the next thing, the year is always a correct thing. Years are always correct. So what do we have to do? The next step is that we need to check if the day is valid, right? We're going to check if the day is valid for all three of these, in each of those, but we're not going to care if it's a leap year yet, okay? Leap year is going to be its own thing that we can easily kind of check, okay? So for over here on top, we're going to do valid 30-day month. So how do we know? So now how do we check if it's a day? If day, well, we got to check that. And I'll leave you to do that. And basically you want to check if it's in the 30-day, if day is in the 30-day range, right? And if it is, awesome. But if it's not, you want to tell the user that it's invalid, right? Right? If it's a good day, you get to print out that the day is valid. But if it's not, you print out that the day is invalid. So I'll leave that to you, and then we can easily take that and modify it for the other two. Unpause. So what we've got here is that we need to now check. So if day, so I'm just going to make some room so it's easier to read. If day, so we want to check if it's between 30 and if it's between 1 and 30, right? So I'm going to do this the way that you have to do this in other programming languages, which is you have to use an AND here. If day is greater than 30, sorry, not greater than 30, greater than or equal to 1, and day less than or equal to 30, print valid date, because we know that that it's a completely valid date, right? If it's greater than or equal to 1 and it's less than 30, then it's in between those things. We can, and then I would do else. And if you had something else, don't worry, we're going to get to that. It's fine. Invalid date. Okay. Now, there's other ways to do this one. You could have done it the complete opposite way, which is still completely correct, which would have been something like this. If day is less than 1 or day is greater than 30, print invalid date. Does somebody know what mathematical law I just used there to do that, by the way? The name of that? Anyone? Anybody taken Boolean algebra yet or no? Yes? De Morgan's, yes! That was De Morgan's law in action. Basically, it's here just simply put, because I switched a positive statement to a negative statement, I switched it from an and to an or statement. So you'll learn more about that as you go on, but in this context, because it's not abstract, it makes total sense. If it's in this range, both of these conditions have to be satisfied. But if it's out of the range, it only has to satisfy the being out of range of one of the conditions, right? So, and then we would put an else over here. Print valid. So everybody sees how that is also completely correct, but just simply done in reverse. Either way works. If you put either on an exam, as long as it works, I'm happy. You know? Now, I mentioned that this is the way you have to do it in other programming languages. Also in other programming languages, you have to do the weird thing of actually having to write it like this. Right? It uses the and symbol, and double and for that, and it gets all kind of, which is different than a single and, by the way. Make sure you don't do that, because that can have unintentional consequences. No. Anyway, but I mentioned that this is the way you would have to do it in the logical statement you'd have to make in other programming languages. But what I love about Python is it doesn't have to be this way. In Python, you can do it like you would do math. You can write this in Python. And I was thrilled the minute I found out I could do this, where I could do a compound inequality like that. Right? That's a lot easier to read. This makes sense, right? That parses a lot easier. Right? Let's go ahead and test that out just to make sure I'm not, completely full of baloney. Right? So, right, we want to check April. Valid month, valid date. So I've checked April 25th. So now I'm going to check April 90th. And that's an invalid date. Right? Make sense? And finally, I'm going to check the 0th day of April, April 0th. That's invalid. Okay? So that works. And what's great about this is that we can pretty much see here that this is super easy to copy paste into our other parts, right? We don't really need to include the valid month statement. Okay? Actually, it's fine. But what we'll do, but it doesn't matter, honestly. We can do this, and we just copy paste it into here. If days between, and all we change is, since it's a 31-day month, we just change that 30 into a 31. Make sense? And now it works for that one. And now, for February, what we do is that we say, well, what do I know about February? If it's February, if it's between 1 and 28, right, inclusive, then I know for a fact it's going to work. Make sense? And if it's greater than 29, I know for a fact it's going to not work. So the only question I have is if day equals 29. And if it's the day is equal to 29 and it's a leap year, it's valid. Otherwise, it's invalid. So how do we do this without our code looking like a giant tangle of spaghetti? Okay. So I'm going to pass right here for a second. And the answer is that we are going to write a separate function to check this. And what do I mean by that? We can just simply say, and is leap year. When I write a lot of times when I write functions, if I have it as a question, like is something, if it starts with is, you can generally kind of guess that is going to give me a Boolean, a true false back. And is leap year, and I've got to give it something year. I mean, I didn't know I had to give it something, but I'm going to go ahead and scroll up to the top and write this Python script, this by itself. So if this, but before I do that, print valid leap year. Boom. Okay, just for debugging purposes, we can say it's a leap year there, and is leap year. Right, so it has to be, the day has to be 29th, and it has to be a leap year. So how do I check if it's a leap year now? Well, I'm going to write that function now. Def is leap year. Okay, and this is where we're going to have to use return. Now the answer is that it gets messy. It gets messy. This is the part where I say it's difficult no matter kind of what, because you either have to write a nasty compound if statement, right, with ands or ors in there, and it can be kind of nasty, or you have to make a bunch of nested if statements, which is fine. Either way is fine. It's just like there are elegant ways to do it, but you have to like go through all the logic to understand the elegance, and it's a pain. So anyway, good luck. Have a crack at it. Okay, if it's a valid leap year. Now remember, what are the rules for a leap year? If it's divisible by 4, but not by 100, unless it's divisible by 400. there's a bunch of different ways you can take a crack at that. You can try starting by checking if it's a divisible by 4 year, or you could start by checking is it divisible by 400. Why would I want to do that? Well, if you know if it's a year divisible by 400, you definitely know it's a leap year. Okay, so get started with that. And then I'll give until 3:10, and then I will come back and I'll give you the answer to this, okay? So I'm going to go about this basically the least painful way I know how, because generally the way we start by doing this is actually it leads to some fairly painful code, which is like if year is divisible by 4, right? This is the painful way. If year is divisible by 4, then I have to do something, pass, else return false, right? You got to return over here. Okay, if it's divisible by 4, it might be a leap year. If it's divisible by 100, though, right? If year is, or if year, oh, I have to check, right. I have to do equal 0 there. Although this would work technically because of truthiness and falsiness. Let's go ahead there. If not year divisible by 100, right, then return true. So if the year is not divisible by 1, if it's divisible by 4, but it's not divisible by 100, yes, awesome, it's a leap year, great. But else, it might be it's divisible by 100, right? Well, it might be true or false, so I actually have to do an elif. Elif, not an else if, but else. Let's go ahead to here. Else, if year is not divisible, if not year mod 400, so if it's not divisible by 400, right? See what I mean? It's painful. Return false. Else return. Look at this beautiful bit of pasta I've made here. It's terrible. It's all tangled, right? So I'm pretty sure this would work though. But let's look at maybe a bit of an easier way to do it now that we've kind of gone through the logic once. Okay? Let's go ahead and maybe take a bit of a cleaner crack at it with the way that I hinted at it first, which is rather than starting with if the year is divisible by 4, I'm going to do the weird thing and I'm going to ask if the year is divisible by 100. 400. If year is divisible by 400, there we go. And yeah, it wouldn't work if I left out the 0. It'd give me the opposite of what I want. Okay, so got it. Yeah, I would need to put in the zeros here. Sorry. So if year divisible by 400 is 0, then we know it's a leap year, right? It's got to be a leap year. If it's divisible by 400, it means it's divisible by 4. And we know that years divisible by 400 are leap years. Return true. Else, or elif, year is divisible by 4. Then maybe it's a leap year. Pass on that. Otherwise, it's not a leap year. Return false. So we can actually just turn this into a fair, and here's the trick. We're pretty much done. If it's divisible by 4, and, got to remember to do this, and so if year is divisible by 4 is equal to 0, so if it's divisible by 4, and year mod 100, and I'm going to just do not equal to 0. Return true. A lot cleaner there. and that actually covers our cases. We don't have to worry, so what's going on here? By checking 400 first, we don't have to worry about it being about checking if it's divisible by 400 over here. We've already checked that, okay? So over here, we're just making sure, is this a year that's divisible by 4 and not divisible by 100? That's it. And you might be going, but what about years divisible by 400? Well, if it was divisible by 400, we would have caught it here. So we don't have to worry about that. We can kind of just mentally exclude all the years divisible by 400. And the rules suddenly become a lot simplified. So let's go ahead and check this and see if it works. I hope it does, because otherwise I'll look really silly. So run. So to check if it's a leap year, again, it doesn't really matter. Once again, it doesn't really matter if it's a leap year or not if the other stuff is wrong, right? We don't care about April 29th, right? We care about February 29th, which would be 02, right? Which says it's a valid leap year. All right, what about the year 2100? That should not be a leap year, right? Invalid date, valid Feb. So let's go ahead. Where am I? Yep, invalid date, valid Feb. That makes sense. So because I accidentally have, so I should move this somewhere else. All right, we don't need to print out valid February, but there we go. Invalid date on 2100. But for the year 2000, which was a leap year, and why I thought, oh, it's years divisible by 4 are leap years for the longest time, right? Because 2000 is that weird 400 year thing. It's a valid leap year. Now, the Gregorian calendar, so this is it. So the Gregorian calendar really does very closely approximate the rotation, the Earth as it goes around the sun and how long that takes. So the drift is a lot less. So it's a really cool tool. And now you know that, but it's funny that, you think you know something so well, like a basic fact, and it turns out that those basic facts are actually way more complicated than you give it credit for. So, all right. What I'm going to do right now is I'm going to take this, I'm going to drop it in Discord. And then I think I do Python like that. Yes. And then I do paste. And then I do okay, why can't I send it? All right, well, I'm going to pause recording for a second.